Welcome to the Explainer. Today, we're going to pull back the curtain on a critical standard that quietly ensures the quality and safety of, well, pretty much everything you rely on.
I mean, really think about it for a second. When you get a blood test or you use a product that's been tested for safety, you're putting your trust in the laboratory's results. But what is that trust actually built on? It's not just blind faith, that's for sure. It's a rigorous, globally recognized system.
And right at the very heart of that system is this powerful international standard, ISO/IEC 107025. You could think of it as the global benchmark that proves a laboratory is technically competent and, most importantly, can be trusted. So, here's our game plan for this explainer. We're going to walk through what this standard is, break down its core principles, see how a lab actually builds its competence and manages for quality, and then we'll look at why this all matters so much on a global scale.
Okay, let's dive right in. First things first, we need to understand the what and the why behind this powerhouse of a standard. So, this was developed by two major international players, the International Organization for Standardization, you probably know them as ISO, and the International Electrotechnical Commission, or IEC. But you've got to understand, this isn't just some flimsy set of guidelines. Oh no, it's a complete quality management system designed specifically for labs. It's the proof that they have the right people, the right processes, and the right equipment to produce valid results every single time. The standard itself is just built so logically. It's not a random list of rules. It's more like a true blueprint for building a trusted laboratory from the ground up. And that's exactly how we're going to walk through it, section by section. And this visual illustrates that structure perfectly. You can see it's organized into 5 key sections of requirements. It starts with those general principles, then moves through structure, resources, processes, and finally, the management system that holds it all together. Let's start at the beginning. It all kicks off with 2 principles that are completely non-negotiable. First is impartiality, which just means there are 0 conflicts of interest that could influence the results. And second is confidentiality, meaning a customer's data is always protected. These 2 right here, they're the absolute bedrock of trust. Okay, so once you have that foundation of trust, how does a lab build on it? Well, you can't get reliable results out of thin air. You need the right components, which brings us to the tangible stuff a lab needs, its resources and structure. Section 6 is all about having the right tools for the job, and that means having competent, well-trained people. It means controlling the lab's environment, things like temperature and humidity, so it doesn't mess with the results. It requires that every piece of equipment is precisely calibrated and maintained. And this is crucial. It demands something called metrological traceability. Now, that sounds complicated, but the idea is simple. It means that any measurement a lab makes, let's say a kilogram, can be traced all the way back in an unbroken chain to the single international master standard for a kilogram. It's like a family tree for measurements, ensuring everything is spot on. So, with all the right resources in place, the standard then lays out the processes a lab has to follow to make sure everything is consistent. This is where the day-to-day work gets done, all inside this quality-controlled framework. Section 7 details the entire workflow, from start to finish. It begins with just reviewing a customer's request to make sure the lab can actually do the work. From there, it covers selecting and validating the right testing methods, handling the items properly, and constantly monitoring the results for validity. Finally, it gets into how to report those results accurately and even what to do if there's a complaint. It's a complete end-to-end process map. But here's the thing. Following a process once is one thing. A truly competent lab has to have a system to ensure quality every single time. And that's where the management system comes in, because it drives continuous improvement. And what's really cool is how the 2017 update modernized this whole thing. It shifted from these rigid, you must do it this way kinds of rules to a much more flexible, performance-based approach. One of the biggest changes was moving from just preventative action to this much broader idea of risk-based thinking. So now labs proactively identify and manage potential risks and opportunities. It's not just about avoiding mistakes, it's about innovating and becoming more efficient.
This final requirement section gives labs a choice, which is pretty neat. They can either build a standalone management system, or if they're already certified to the famous ISO 9001 quality standard, they can just integrate it. But either way they go, they have to have key elements in place. Things like document control, a process for addressing those risks, regular internal audits, and management reviews to make sure they're always getting better.
So we've seen the what and the how, but what's the ultimate payoff? I mean, why would labs go through this incredibly rigorous process to get accredited? Well, as this quote makes pretty clear, accreditation is so much more than a piece of paper you hang on the wall. It's a powerful signal of competence. It builds tremendous customer confidence, boosts the lab's reputation, and opens doors to all sorts of new business, especially in global markets. And that right there is the ultimate goal. The standard creates a common language of quality that's understood and accepted all around the world. This makes international trade so much smoother by reducing technical barriers. It allows a product tested in one country to be confidently accepted in another without all that costly and time-consuming retesting. This whole framework of trust provided by ISO/IEC 1705 is a vital but often invisible part of our modern world. It's ensuring reliability in everything from healthcare diagnostics and consumer electronics to environmental safety. And it really makes you wonder, doesn't it? What other hidden standards are quietly working behind the scenes to keep our world safe and functional?